Hi and welcome to this week's video. All the half ribs have been completed, all the lower wing ribs have been completed except for their stiffeners. I have finished all the forward spars. As you'd have seen, I did the aileron bell cranks. We've got the main forward spars all done and dusted with their boxes, which you saw in the last video, me creating the initial boxes. That's all been drilled, bushed, and the doublers, also the packers, having been placed in there, the same as we did for the lower forward spars. You might notice there's a thin spar there. That is the first of the upper wing rear spars. It's about ready now to be drilled for the bushings and then have the packers put on, so not far off being complete. And there's one laid up, just curing at the moment, about half finished. So I've got a few little bits I'm going to show you in detail, so let's have a little look at that. Okay, so we've got our line drawn out here, 28 inches from the root. I've drawn a centre line going through, looking at the original bell crank setup according to the plan. The way we'd have ended up with the bell crank being dead on the centre line of the spar, which is quite logical. So with my setup being very slightly different width, I've got my blocks on here. I've put a stainless steel washer on each side, which would be acting as a sort of bearing bit. They would be bonded to these in the end, just to make sure they're there. And then with this just in, so that's a nice free movement. The measurement going across here, which I've measured in a couple of places to get an average, is 18 millimeters, which is spot on for life. We've got, so what I did was I've drawn a line 9 millimeters out from each side. That'll be where the sort of blocks, top face of the blocks will go. If I center that up on the cross, I want to come out to there. So that's how far out we need minimum clearance. We're going to add a little bit more to that. I'll just get my square. So that would be where we would be there. I want to have a clearance on top of that of about 3 millimeters, 1/8 of an inch or so. So that's where my cutout's going to there. We'll work out what the thickness is going to be here with the stiff nuts on, so I can work out how much I need to go above. So give me a moment, I'll just find the stiff nuts. This section here, to allow for the fact I'm going to be using castellated nuts on there, I've made that 12 millimeters below the centre line, and to allow, just to make sure the head doesn't go, I've made that 10 millimeters, which is a lot less than the 2.5 inches it shows on the plan. So 2.5 inches it'd be sort of right down here and right up there. I don't see the point of taking out that much extra material. This is the width for everything. The block will stop about here, so I'm just going to go up just a little bit more. I'm talking about a millimetre extra on each side there. That just allows, just in case we get any wobble in the bearing so it doesn't catch. I don't like having squared corners, so this will be rounded off, something in that sort of format. So, rounded, and rounded each of those corners, and of course back there that'll be rounded, and that will have a little rounded section into it there. So I'll deal with that now, and I'll show you what my end result looks like. I've just drawn an extra line on here, 1/8 of an inch forward. That allows me to utilise that for making sure that I've got this right. I've got this whole long axle rod through to allow me to make sure everything is vertical and square. I've got the blocks on the edge there of the cutout. With that now set as it should be, I can just draw around the block. And now I've got a good range of movement, nice and free. It's all centred. We've got enough clearance there on each side. You sort of see we've got 1/8 of an inch clearance there. There's good clearance for the head of the bolt. If I take that off, now we know exactly where the pads are going to go. I've given this a good rough sanding across the grain. I'm ready to take a key. I can bond the blocks into position there, and with the blocks bonded in, it's all done outside. It makes it a lot easier than trying to do this with the wing fabricated with the ribs in position. So I'm doing it now. So there is the bell crank area, just in close up for you. As you sort of see, I've removed the majority of the squeeze out from the outside, especially on this inner edge just down here, so nothing will rub on the bell crank. So one spar complete, get the other one done, and that's both the forward lower spars finished, ready for wing build. Just go get the other ones done. I get my pieces of ply, I give them a wipe down with denatured alcohol. It gets rid of a bit of any sort of surface stuff that's there, release agent that they might use for the ply. Then 80 grit. I'm just going to go across the whole surface. Across the grain. Because this denatured alcohol is very volatile, it's evaporated off already. So I'm going across all of it. Now taking a different area. I give it a wipe down again. That helps to get rid of the dust from sanding it. I'll now let that fully dry, so quarter of an hour now before I use the epoxy on there, but they're essentially ready to bond. The reason I leave it a quarter of an hour is because that gets right into the surface. I just want to make sure it's completely out of the surface so it doesn't affect the resin at all. And that's going in line with the nearly all the aircraft manuals that I've come across to do with bonding plywood. So I'll do the spars themselves, and I do that with all the spar capping pieces. Okay, slight error I think on the drawing, which just worries me just a little bit. It says here that the W12 block, the infill block between the two cap pieces, starts at 70 1/4 inches, which is after the centre line of the vertical piece here, which says 16.9 1/2. So that would mean that these two bolts here and here would be just going through the plywood gusset plates, the filler packer, and a plate on the front, plywood 1/4 inch, and the plywood web of the spar, and nothing else. I think that's a little bit in error there. So what I'm planning to do is to give 3/4 inch edge distance, land as I call it, between the edge of the hole and the edge of the block, the same as it is for the main spars. The block would start here at 68 3/4 inches. So in line there is 68 3/4 inches. That is where I'm going to start the block, with 6 inches of wood there. I've put the two pieces of aluminium together to check with the angle set at 35 degrees, and that gives me just over 3/4 inch, 7/8 inch edge distance from the hole there to the edge. So at least, so that gives us good land on both sides. That's to me the structural way to go. That's number one area of work there. The other bit which I find a little bit different is if I just move up this section here. It's got infill with W12 block, and it also mentions W31. In accordance with the parts list, W31 is ply gusset. So I'd anticipate that being something which would go across the top of the two capping pieces, holding them together as a gusset going across in plywood. Well, it's not quite like that. The W31 that I've got is just slightly short of the distance between the two capping pieces, 32nd of an inch short. That's not the thickness of, so it would act like the infill block. The thickness of it though is 1 millimeter thinner than the capping piece, so be a big lump of gap there between that and the sort of 16th and 1/4 inch ply, which go up to make up the thickness for the vertical there. So what I've done, rightly or wrongly, is I've machined up a piece of wood because there wasn't enough W12 to go in there. There's no spare. Having cut all the other blocks, that is all the spare I had. So I've made up from a piece of white pine that I had with good grain on it, I've made up a piece with the grain actually running vertical, the same as it is for the other areas, to go between that, which is the same thickness as the Spar caps, same thickness as the W12. We've got verticals going all the way along here. There is no vertical at the point where that rib is. Now, there's no need for one there to do what these verticals are meant to do. The verticals are there to stop the two capping pieces from being able to go together. That's the whole point of the web. The web keeps the capping pieces apart, hence the grain is more vertical. The plywood grain is the outer plies of grain is vertical, with the inner plane ply section going longitudinally. That gives it the stiffness needed top to bottom, because the whole idea of the web is it stops the two Spar caps from going together, and then the little vertical pieces here help to stiffen it up even more, because it's only 16th ply, it would flex and things like that. So that's what they're there for. So it doesn't need one there because we've got a great big block here. But having said that, the ribs glue in these positions, so you're losing out a little bit of the glue joint on the rib geodetic for the rear Spar mount there. So I'm going to add an extra on. That's going to add a minuscule amount of weight, but it just makes the rib bond a little bit better. Right, so looking at the tips where I've cut these bits off, as I did before, and I'll show you on the rib. Excuse me while I move you about. Here's the cord line going along, and I want my bow to be centered on the cord line. So if I measure to the top of the cord line to the bottom of the Spar, it's 1.5 inches. The bows are 1/2 inch thick, so I made that 1.25 inches to the bottom of the bow. So what I did was I just measured out on the ply tip the 7.5 inches, measured up 1.25 inches, drew that line, 1/2 inch above that, drew back that line, and that gave me the position and shape for the ply at the tips. The dimensions aren't given on the plan at all for that, so yeah, hence I'm showing you how I got around it from my point of view for classic standard tips. I made the infill block here very slightly longer than that on the plan, just to allow for the inaccuracy that was there, but I made the 1/4 inch packer very slightly less than 6 inches. Wasn't quite enough there to allow for the curve of the saw, so it's made very slightly shorter, and the width of it, as you can sort of see, that was produced was slightly less than the full width of the Spar. So what I did was I've set that so it's flat on the bottom, because that's where everything's hanging off, and double check to make sure that the straps would fit and would still be resting on it. This doesn't really change the strength at all. I've got a slight step at each side there, and that is in the correct positioning to allow for the bracketry to go there. So there's the gussets. The end stiffeners just the same as for the forward spars, and then we've got the block section here all ready for the metalwork to go on. So I've had to make up 3 different thicknesses of bushing. One thickness for here, which is the thinner stuff, 5/8. One's for the verticals here, and then of course it'll be thicker for where the diagonals are, because it's going to be packed by 1/8 of an inch on either side, so it'll be 1/4 inch thicker. So there are all the bushings just prepped. They're going to be machined down to their final length once I've determined that. Well, that's it for this week. We managed to get through the first quart of glue since we received the kit, and 150 hours total so far has been spent on the aircraft with the tail and the wings. So I don't think we're going to quite make it to that 400 hours as quoted, but we're making really good progress. Hopefully in the next week we'll have the lower wing rear spars created, and we can start getting ourselves set up for putting a wing together. We'll find out how close we get to that. I'm not holding my breath. Catch you next week. Thank you for watching. If you enjoyed the video, please hit the thumbs up. You can subscribe or even hit the little bell notification for future videos. Any comments would be appreciated, and I'll try to get back to you as soon as I can. Remember, go fly and feel the sky.